Hello and welcome back to the course on applied econometrics. In this lecture, we are going to touch upon the multiple regression. Now, in the previous lecture, we have seen how simple regression works and we have plotted y and x and we have seen the different components of error. Now, let me recap. Let me actually draw it. So, we had this coordinate system where I had explanatory variable x and my dependent variable y, and I got a lot of different points which are actual observations for x and y. And now what I have to do here is I have to actually draw a regression line, and we have seen that we can actually draw a regression line by minimizing the sum of square of error terms. Now, so that we know, and we sort of explained that if I have say a line here, say this is the mean value of all the y's and I get it y bar. So then I need to sort of divide the error terms into different components, and we have seen that we can actually divide this error term. So one error term is the line. So this part of, say, let's say we are talking about this point, and then if we the total error from this point, total distance of this, say let's say yi from y bar is this length. Now, if I divide this total distance into different components, I have this component and I have this component. Now, the first component here, it is explained by my regression line, and I can call it, this is the explained error. We have sort of defined it as explained error, and the other part of the error is not explained by my regression line, and we call the residual error. This part is called residual error. Now, for all the different points, in the same manner, if I get the error terms and if I actually divide the error terms into two components, one is the residual error and another is the explained error, so we can actually get the sum of the different error terms, and we have seen that we actually square all the different error terms. So we essentially what we get is sum of square for these different components, residual and explained. So how we sort of express them? We express them SSR, sum of square for residual error, and we term explained error as SSE, sum of square explained, and the total error SST is equal to SSR plus SSE. So we have seen it already. Now, this is for the simple linear regression. And if I want to have more than one variable, so here I have only one variable. Let's say this x variable here is my, let's say, my education, okay, and my y variable here is, let's say, my income or earnings. So I kind of presume that or actually what I see from the data is that my earnings is actually increasing with the level of education, and that's what we see from the data. But suppose if we want to have more than one explanatory variable, let's say I want to have, say, experience, because I know from my knowledge that people who have more experience, more work experience, they earn more. So it is not just the education but also the experience which matters when it comes to the earning. So now how do I actually sort of capture the impact of other variables? So only when I consider more than one explanatory variable, then it becomes a case of multiple regression. So here it's a simple regression, this one. So here we write, say, fx y is equal to, say, simply fx, and where my x is education. But when I have more than one explanatory variable, so y is equal to, let's say, f of x1, x2, it is a case of multiple regression. So here I write simple linear regression. We are only talking about linear regression, and here we call it multiple regression. This is also a linear regression, multiple regression. Now we'll try to explain graphically how a multiple regression is different from the simple linear regression. So let's go back to the same example, education and earnings, but here I am going to add another line, and that is for my experience, okay. So let's say I have drawn another line, that is experience. So this is my education, this is my earnings, and this is my, say, experience. All right. So here I am just considering two explanatory variables, not more than two, because we know that we have limitation in terms of how many dimensions we can plot. So here is a three-dimensional system where we can plot at max two explanatory variables. So if you ask me whether we can plot like three explanatory variable, we cannot, or four explanatory variable, we cannot. So our limitations is this, that we have to plot in a three-dimensional plane, right? So that is the maximum we can do. But the concept goes like this: you can actually think that there are multiple planes and you can actually keep on adding the different dimensions. Okay, so here we have two dimensions. One is, in one dimension we plot education, in another dimension we plot experience. Okay, and the outcome variable or the dependent variable is earning. So as we had in the previous case. Now how do we really get the regression line? That is what we have to see here. So just like in the previous case, we have seen previous case we had this line. Let's say we extend this line up to here, and if we extend this line up to here, we have this intercept term. Let's say we term it as a b1, and then you have a slope, and this slope is, say, let's say b2. So then I will write my regression equation, the regression line. So I can write y hat is equal to, say, b1 is the intercept term plus b2 into x. All right. So all these different x variables, if I plot, I will get this estimated predicted y. So predicted y is always represented as y hat. All right. So this is basically the line that we have created. So that is what is this equation representing. Now here also we will have, say, we want to sort of understand the impact of education. So let's say there is an intercept term here. So let's say it is some b1. It is not necessary that the two b1s are same. We are just we are just maintaining the same notation so that we don't have any confusion later on. So this is the intercept term like we had in the previous case, and then you actually try to estimate the impact of, say, education. Let me use a different color here. So you want to see the impact of education and impact of experience. So impact of education would be measured by the slope coefficient, and the impact of education, let's say the slope coefficient for the impact of education is going to be b2. Now if that is the case, and if I draw my regression line here, so just the same way let me use the same color, the red color that I used in the previous case. So if I draw the regression line here, I'm just considering the impact of education. I'm just considering the impact of education, and let's say this is the angle here, and let's say this is b2. All right, so this is b2, and then this line is basically representing the impact due to education only. Okay, so the regression line here would be for this line is going to be earnings. I can actually write it as earnings is equal to b1 plus b2 into education. So this is pure effect of education. We can say that this is the pure effect of education. This is the intercept term. This is the intercept term. This is a pure effect of education. This part is a pure effect of education. Now we will also be interested to actually understand the pure effect of experience, right? Because all these different components do matter when it comes to earnings, because we have already specified in our model that it is both education and earning which matters so far as my education and experience so far as my earnings is concerned. So if I try to also estimate the impact of experience on earnings, so I will again get the pure effect due to experience. So in this, when I talk about pure effect, it is not mixed up with the effect of education or the intercept term. So intercept term is already there. Then I measure the impact of education on earning, and then I also measure the impact of experience on earning. And let's say the line goes like this. All right. So this is the impact of experience, and the angle, let's say, is B3. This angle is B3. All right. Now, if I try to sort of understand what just has happened is that, so let me actually complete the diagram. So we can basically sort of draw the projection here. This is the projection, and we can actually get a resultant of both these lines, both these two lines. So this line, this line is actually, this line is actually representing the pure effect of earning. So here, if I just consider this particular regression equation with B1 and B3, what I will have is earnings is equal to B1 plus B3 into experience, all right. And this part is pure effect of experience, and this part is pure effect of education, all right. Now, I want to, at the end of the day, since I am considering a multiple regression, I have different explanatory variable, I need to get a sort of the final regression line that I want to get from all these different impacts, right. So, what I will do, I will basically draw a resultant line. So, I have this line due to my pure effect of education, I have a line due to pure effect of experience, and then I will get a resultant line. How do we get that? It's simple. We will sort of get the resultant line, and let's say I again draw some projections here. And let's say this line goes like this. Actually, this line should be parallel to the previous one, right? This should be parallel to this one. So, it will be like something like this, and I will have another line which is parallel to this line, so which will be like something like this, all right. And then if I draw a line from the origin or from this point where my intercept ends, so what I will get is this line, right, or essentially this kind of represents a plane, because I am considering more than one dimension here. So, here I will have the final regression equation where I will actually consider all the impact of education, earning, education and experience on earning, okay. So, this is what is the impact that is going to be. This is the impact, all right. Oops, this slide ends here. So, this is the impact. So, if I draw it, so this is the total impact. This is the total impact due to education and experience. So, total impact. Now, that is basically my y value, that is the predicted y, right. Now, there is another component, that is the error term. So, we need to consider the error term also. So, the error can go, so this is the predicted y value. Now, the error can go actually above that. Error could be positive, error could be negative. So, anywhere you can consider the error. Suppose my error is negative ui for that particular yi. So, then in that case you will basically subtract the ui, or depending on which side the ui is, you will add or subtract the error term. So, now we have graphically understood how it will be like when we draw a multiple regression, and when we actually draw it, sort of do a visual sort of depiction of the multiple regression. So, we have seen how it would look like. But at the end of the day, what we will want is, we want an equation like this, right. So, here for multiple regression, my equation is going to be, again my earnings or y hat is essentially nothing but B1 plus I will have my B2 into education plus B3 into my experience, right. So, this is my predicted regression equation, which I am basically trying to derive from the different explanatory variables. So far that's the basic illustration of multiple regression, and going forward we are actually going to use some data to show how multiple regression works, and we are actually going to show you how these different lines that we have just drawn, these actually matters in terms of explaining the data. So, we will see with that example, and also we will talk about a regression table, like when we do a multiple regression, there are different elements in a regression table. So we need to understand each of these different elements in a regression table. They're very important, and we will do that in the next lectures. Thank you.